Electricity. Heating effect of electric current. Touch your cell phone which has been charging. Touch the CPU of your computer or the television or the mixer which has been running for some time. Do you feel heat? Why do the electrical appliances get heated when we use them? This happens due to the heat generated as a result of heating effect of electric current. Let us learn more about it. What do you mean by the heating effect of electric current? The energy can be transformed from one form to another. When current passes through an appliance such as mixer, it gets electrical energy. What happens to this energy? Where does it go? Some of the electrical energy supplied to the mixer is used for its mechanical function of rotating the blades, whereas the rest of the energy is released as heat energy, making the mixer warm. This process of transformation of electrical energy into heat energy due to electric current is known as heating effect of the electric current. Why is heat produced on passing the electric current? Let us understand this with the help of a circuit with a battery, conducting wires made up of copper and a resistor made up of nichrome. When the current is passed in the circuit, the nichrome wire is heated red hot, while the copper wire is hardly heated. To know why this happens, we have to compare the structures of the materials. The copper wire has a network of positively charged ions, that is, the atoms which have lost their electrons. These ions can vibrate, but they cannot move freely. Then there are a large number of free electrons which can move freely. The nichrome is an alloy of nickel, chromium, and iron, and so it has the network of 3 different ions. But the number of free electrons in nichrome are lesser as some of the electrons are involved in bonds with different atoms. These bonds also restrict the number of pathways available for free movement of electrons. So, when the current is passed, the electrons in copper flow easily, and a few of them collide with the vibrating ions. In nichrome, the electrons cannot move ahead easily, as they are resisted by the bonds. Most of these moving electrons collide with the vibrating positive ions. During these collisions, the energy of the electrons is transferred to the positive ions, and the ions begin to vibrate more vigorously. This energy is released in the form of heat. The lesser number of collisions in copper release very little heat energy, and it can hardly make the copper wire hot. Whereas a large number of collisions in nichrome release much higher amount of energy, making it red hot. Heating effect of electric current is also known as the Joule's heating, because it was first studied by James Prescott Joule in 1841. Joule's law of heating states that the heat produced in a conductor is directly proportional to the square of the electric current I passing through the conductor. It is also directly proportional to the resistance R of the conductor and time t for which current passes through the conductor. It is given by the expression H is equal to I square into R into T, where H gives us the amount of heat generated. Based on the Joule's law, we can say that to get more heat generated, we have to pass more current for more time. As the resistance is directly proportional to the heat generated, the materials that have higher resistance to electricity, such as nichrome or tungsten, generate a large amount of heat as compared to copper. This property of tungsten and nichrome is used in several appliances where electrical energy is required to be converted to heat energy. Let us see an interesting demonstration which shows the use of tungsten, a heating element in our daily life. Take a circuit with a battery, a bulb, and wires connected in a loop. When the current is passed through the metallic wires to reach the bulb, the filament of the bulb gets highly heated and emits light. But the wires get a little warm, and we do not see any light from the wires. Let us find out why does this happen, though the current supplied to the bulb and the connecting wires is same. A bulb is a closed container with inert gas and a very thin filament. This filament is made up of tungsten metal, which has very high resistance to the electricity and extremely high melting point. Opposite to this, the metallic connecting wires are the conductors made up of copper with extremely low resistance. Due to this, the entire resistance of the circuit is concentrated in the tungsten filament, and almost all the heat is generated in the filament. Hence, the filament gets extremely hot and heat energy is converted to light energy. Whereas the low resistance of copper wires causes low amount of heat generation. This heat can make the wires little warmer, but it is not sufficient to emit light. The electric energy supplied to an appliance is converted into heat energy and other forms of energy such as light energy in a bulb. This conversion of energy happens at different rate in different appliances and is indicated as electrical power of the device. Electrical power is defined as rate at which electrical energy is converted by an electric circuit. The SI unit of electric power is watt, indicated by W. It is given as a product of voltage and current. Let us consider 1 coulomb per second charges. That is, 1 ampere current is flowing in a circuit with a bulb having voltage of 220 volts. We observe that the bulb glows with moderate brightness. The power consumed by the bulb is 220 watt. If we increase the rate of charges to 2 coulomb per second, that is 2 ampere current, then we observe that the brightness increases. The power consumed by the bulb is 440 watt. As more charges flow, more energy is available to transfer into light energy per second, and we say that the bulb has more electrical power. Now, let us explore a few questions that might have wondered you sometimes. The electrical appliances such as toaster, iron, hairdryer, or room heater have metallic filaments or coils. Do you know why? You might have experienced that the electrical supply of your house suddenly breaks when a fuse blows off. Do you know why this happens? Let us find out the answers. These devices are provided with the coils or filaments which act as heating elements. When the current is passed through these devices, the filaments or coils get heated up and convert the electrical energy into a large amount of heat energy. An electric fuse is an important application of the heating effect of current. A fuse has a thin piece of wire designed to carry a limited current. When the current drawn in a domestic electric circuit increases beyond a certain value, the fuse wire gets overheated due to heating effect and melts and breaks the circuit. This prevents fire and damages to various electrical appliances. We have learned about the heating effect of electric current. Now we have a question for you to think about. We do not see any filament in a microwave oven, but we see it in a toaster. Do you think that the Joule's heating is used to heat the food in a microwave? Or is there a different principle behind it? Find the answer yourself.